In this video, I'll create control events that will modify the game model as the players take actions. I'll add buttons to the player interface and create their callbacks, which will in turn add the game control events to the timeline. I'll also add an undo and quit button to the user interface. I'm going to start by creating the timeline control events. In Unity, add two event classes, one called pPayChip and another called pTakeCard. Both of these classes are going to be derived from playerEvent, which is a type of timeline control event that is created by a player action. The constructor requires a player. I'll use the game's current player member since only the current player can take an action. An event has a do function, which updates the game model, and an act function, which draws the user interface and does any animation or sound effects. TakeCard event's do function needs to give the top card of the gift deck and any bid chips to the player. It also needs to reset the center chip count to 0 and move the game's current player member to the next player in turn order. Finally, it needs to check if that was the last card in the deck and trigger the end of the game. The act function will eventually animate the chips and card, but for now I'll just redraw the whole user interface. The return value is the number of seconds to wait before executing the next event on the timeline. pPayChip is another player event. Here the do function needs to remove a chip from the player, add it to the center, and move the current player of the game to the next player in turn order. Again, the act function will just redraw the whole user interface. Now I'll add callback functions to the GUI classes which create these player events. These are the functions that will be called by the user interface buttons during gameplay. For this game, the buttons are always active, so I need to make sure it is valid to take the action before adding the event to the timeline. The chip button on the player user interface should only work if the player represented by that user interface is the current player and that player has a chip. If the player doesn't have a chip, I'll have the Windows Voice plugin tell the player that they are out. The gift button is part of the player dialog GUI and is only shown on the current player's user interface, and a player can always take the current gift card, so I don't need to do any checks and can just add the event. That is all the script code that I need to write. Next, I'll add the button behavior to the chip object in the player's user interface. I'll set the transition to none. A future enhancement might be to create a graphic of a highlighted chip so that I could indicate to the player that their chip button is active and clickable using the sprite swap transition. Add a callback of playerGUI.onPlayerChipClicked. Apply these changes to the prefab. Do the same thing for the gift icon on the player dialog and set the callback to playerDialogGUI.onAcceptGiftClick. Apply the change to the prefab. Run the project and test out the buttons. The user interface should instantly draw with the new game state after pressing the chip or gift button. The game is now playable, but there are quite a few things yet to do to make it more polished and complete. Using the timeline and event control system to make changes to the game model allows the game to be saved and loaded and for moves to be undone. This capability is built into the reuse code, and I just need to add buttons to the user interface to take advantage of it. Add a new button named Save and Exit button. Size it to 196 by 48, position it on the right side of the screen, and rotate it to face left. Use the rect_button_0 sprite, set the transition to sprite swap, and use a disabled sprite of rect_button_1. Set the callback to GameGUI.SaveAndExit. The GameGUI behavior is on the controller object. This button will save all the events to a file, and will add a screen to load this save file in a later video. Delete the child text object, add a text mesh object, set it to fill the button, and set the text to save and exit. Duplicate this button, rename it to undo button, and change the callback to GameGUI.UndoAction. The reuse code implements undo by deleting the last event and then re-executing all the other game events. The first game event resets the model, the next events add the players, and then initializes the game. Then all the player-created events are re-executed, and the user interface is redrawn. This is computationally expensive, but saves me from having to write error-prone undo code for each event. In the next video, I'll add animations and sound effects to the event's act functions.